In our latest activity within the Wood Cycles project, we explored how reclaimed wood from demolition sites that usually destined for particle manufacturing can be upscaled into high-performance engineered wood products, specifically cross-laminated timber panels. Around 11 cubic meters of old structural timber, including beams and trusses, were collected from buildings in Denmark. These elements were carefully cleaned with all the nails and screws removed, then replaned and graded to produce boards closely like standard boards made from virgin wood. The key question was, can existing industrial production lines be adapted to process this reclaimed material? As Stora Enso, we brought the industrial and manufacturing perspective to this challenge. To demonstrate this, we produced 2 full-scale CLT panels at our main units, Austria, using the reclaimed boards, following the same industrial processes applied to virgin wood.
Here's how the panels were made. First, the recovered boards are sorted and visually graded. Damaged ends are identified and trimmed. Next, the boards are finger jointed and glued to create longer lamellas ranging from 8 to 16 meters in length. These lamellas are then planned to final dimensions, arranged and glued into single layers. Each layer is cut to the desired panel size. 5 layers are arranged, alternating between longitudinal and cross directions, then glued and pressed together to form the final CLT panel. The raw CLT panel is then sanded to smooth the surface and remove any glue residue or imperfections. At this point, the CLT panel is ready. Beyond production, selected samples from the reclaimed wood were also set aside for further testing. These will help us assess the mechanical performance of recovered wood for structural reuse. The CLT panels themselves will be used in a pilot demonstrator structure that will travel across the 3 partner cities. The activity of manufacturing CLT from recovered wood is important because it shows that reclaimed wood, free from metal impurities, can technically be included in industrial wood products that are designed for structural applications, a key step toward more circular construction. At the same time, however, we saw that there are still barriers to overcome, for example, preparing and cleaning the material, handling differences in wood quality, and updating building standards that are not yet fully supporting reuse. We want to highlight that it is crucial to work across the whole sector with all stakeholders involved in order to create new value chains and business models that enable circular wooden construction.
For Stora Enso, this work supports our commitment to a circular bioeconomy, extending the life of wood materials, reducing waste, and developing solutions for reuse and remanufacturing. And just as importantly, this activity showed the value of close collaboration between industry and research.